Hello everyone, welcome to PJ Chemistry channel. Last video we discussed about redox reaction. In that combination reaction means how to prove the reactions are redox reactions. Same way, today we are going to continuation. See here, last videos as it is combination reaction. Already clearly I said one hint. One side elements, one side compound. Other means that undergoes redox reaction means that takes place both oxidation as well as reduction. Okay. Questions are two types. Mainly the combination reaction. Below the reaction is oxidized or reduced. At the time you have to see element added or removed. Okay. Which element added? Oxygen added means oxidation. Hydrogen added means reduction. Same way, how you prove below the reaction is redox reaction. At the time, we have to see based on oxidation number. Elementary form oxidation numbers 0, magnesium element 0, hydrogen element 0 before participating in reaction. After reaction, these both are combined with hydrogen added to magnesium. At the time, magnesium hydride forms. Hydrogen minus 1, magnesium plus 2. Like that, 0 to plus 2 increase the oxidation number, oxidation. Hydrogen 0 to minus 1 decrease the oxidation number, reduction. Oxidation reduction both are taken place by same equation. That is because redox reaction that we discussed in previous video, combination reaction. Today it's continuation. Yes. One more example. If compounds are there combined, form a single product in the combination reaction. Will it show redox reaction or not? We will check it. MgO magnesium oxide combined with water and forms magnesium hydroxide. Now magnesium hydroxide OH twice. OH twice. Now check it oxidation numbers. Oxygen gain 2 electrons minus 2. Magnesium lost 2 electrons plus 2. Oxygen gain 2 electrons minus 2. Hydrogen lose 1 electron. That is what we given 2 hydrogens. Means to each hydrogen 1 electron. Means 2 hydrogens, 2 electrons lose. That gained by oxygen. Next, hydroxide ion minus 1, magnesium plus 2. In this particularly OH minus, instead of that hydrogen oxygen we want to take hydrogen plus 1, oxygen minus 2. Okay. Now check it. Magnesium reactant side also plus 2, product side also plus 2. No change. No increase, no decrease. Oxygen minus 2. Here also minus 2. No change in the oxidation number. Hydrogen plus 1. Reactant side also plus 1, product side also plus 1. No change in the oxidation number. So in this, no redox reaction. No redox. It is not redox. It is not redox. Okay, there won't be any redox because no change in oxidation number. If change in oxidation number increase or decrease means oxidation, decrease means reduction, we will say. But here, no changes in the oxidation number, reactant side, product side. So it is not a redox reaction. That is what I used to say here means, even though combination reaction, all combination reactions not follow redox reaction. Which will follow, I gave hint, right? One side elements, one side compound. Those reactions only shows both oxidation and reduction, which is nothing but redox reaction. Okay, as a note to maintain, In combination reactions, wait, instead of that, all combination reactions not shows all combination reactions do not show redox reaction. Only reaction which contains only reaction which contains one side elements. Same sentence, same note will be applicable for even decomposition reaction also. Only reaction which contains one side elements and another side compound. Those reactions having redox reaction which contains one side element and another side compound. That reactions shows redox reaction. If two sides also compounds are there like this, they won't participate in the redox reaction. Even quicklime calcium oxide with water it forms calcium hydroxide. That is also not shows redox reaction. Yes, redox reaction. How decomposition reaction is going to show. Same previous what we discussed. That rule is applicable here. One side elements, one side compounds. Other means that compulsory will show redox reaction. Here, see here, decomposition reaction. Reactant side single compound. Product side elements are there. Here. So this will show redox reaction. Like few examples I given, we'll discuss one by one. It is in compound water oxygen gaining 2 electrons. Oxygen atomic number 8 to get stability, it will gain 2 electrons. From where it gain? From hydrogen. Each hydrogen lose 1 electron. Next, after decomposing, elements forming hydrogen, oxygen. Elementary form, oxidation number 0. Now, changes you observe, oxygen -2 to 0. Compared to negative value, 0 is greater. So, oxygen increased oxidation number. Oxidation. Oxidation. Next, hydrogen +1 to 0. Decreased oxidation number. Reduction. Both oxidation reduction takes place by same equation. So redox reaction showing. Next, silver chloride, chlorine -1 gain 1 electron from silver. After decomposition, silver element 0, chlorine element 0. Elementary form oxidation number is 0. So silver +1 to 0 decreased. Chlorine -1 to 0 increased. Increased is nothing but oxidation. Decreased reduction. Same way, okay. Do it children. Do it yourself. HBr, silver bromide. Yes, very good. Silver +1, bromide -1. Yes, elementary form silver 0, bromide 0. Yes, now check the decreasing. Silver +1 to 0 decreased. Silver +1 to 0 decreased means reduction. Bromine -1 to 0 increased. Increase means oxidation. Yes, children, understand? Now, what about lead nitrates? Are above okay? One side compound, one side element, or one side elements, one side compound is there. We got it easily. What about lead nitrate? Yes, how to find out? Redox reaction present in the lead nitrate. See here, for any reaction, if you follow oxidation number method, very easy to overcome your confusion. So, dear students, about oxidation number clear information I gave in the short videos. Okay, once you observe short videos, shorts, you will get a complete information. Now, lead nitrate. See here, find out lead nitrates for each oxidation number. Lead nitrate PbNO3 twice. I want for every element oxidation number here. Nitrate ion. Starting video itself for 10th class I given information. Nitrate ion. Charge is -1. Lead. Here two nitrates are there, no? So one nitrate gaining 1 electron, two nitrates gaining 2 electrons from lead. At the time, lead is +2. Lead is +2. Oxygen oxidation number -2. Oxygen gain 2 electrons. Now here nitrogen. Nitrogen oxidation number is +5. Nitrogen oxidation number is +5. How sir? Nitrogen actually gain 3 electrons, you know, but here +5 telling. Valency means 3. But oxidation number is nothing but there is a maximum possibility. So, see here how to find out oxidation number because this example I am going to explain. First, the given elements you take it as sum. Sum is plus. Lead 2 nitrogens plus 6 oxygens. This all is equals to 0 you consider. According to oxidation number first rule, sum of oxidation number of every element is equals to 0. Okay. Now, write their oxidation numbers. Now, we have to find out nitrogen. So, which is going to find out that it does a X. Lead already we got it now, +2. Lead oxidation number is +2. Nitrogen we need to find out, so I take it as x, 2x plus total how many oxygens are there? 6 oxygens are there. Each oxygen oxidation number is -2. So 6 into -2 is equals to 0. Now simplify it. Plus 2 plus 2x plus into minus minus 6 into 2 12 is equals to 0. Now minus 12 plus 2 minus 10, 2x minus 10, 2x minus 10 is equals to 0. 2x is equals to plus 10, x is equals to plus 10 by 2 is nothing but x value plus 5. That is only nitrogen. What I given here. Okay. Like this, we need to find out oxidation numbers of every element. Now write it. So first one over. Now lead oxide, oxygen gain 2 electrons from lead, lose 2 electrons. In NO2, oxygens, one oxygen means gain 2 electrons. 2 oxygens are there now, gain total 4 electrons. 2 into 2, 4. From where it is gaining? From nitrogen. So nitrogen plus 4. Oxygen here element means 0, fix. So indirectly what we are going to say means at least one element is there also product side, that will show redox reaction. Now see here, check what changes we observed here. Lead, any changes? Here also plus 2, here also plus 2, no change in the lead. Nitrogen, here plus 5, here plus 4, yes, changes. So nitrogen plus 5 to plus 4. Increased or decreased? Decreased. Decreased means redox reaction. Sorry, reduction. Decreased means reduction. Next, okay, reduction over. What about oxidation, sir? Oxidation, if you observe, the next element remaining, which is there, oxygen. Oxygen here -2. Here also -2, here also -2, here 0. So, oxygen -2 to 0. Increased. Compared to negative value, positive value as a 0, more only. So, oxidation. Oxidation. That is what? This also means lead nitrate decomposition also showing redox reaction. Next, go for one more example. You try it, children. Ferrous sulfate decomposition. FeSO4 decomposition. It will form Fe2O3 SO2 SO3. Here only we are getting SO2, 2 oxygens getting to each 2 electrons means 4 plus 4 sulfur. Here 3 oxygens getting means plus 6 sulfur. There only changes occurs. So obviously we will get it. Now solve this. Yes, fast. First find out ferrous sulfate oxidation number. Sulfate ion -2 means sulfate gaining 2 electrons. From where it is gaining? iron. So obviously iron plus 2, oxygen minus 2, sulfur plus 6. So how's our sulfur plus 6? Okay, you can go through the solving oxidation number. Here, previous lead nitrate we solved right like that. On the same, take FeSO4 iron plus sulfur plus 4 oxygens is equals to 0. Iron plus 2. Sulfur we need to find out X. 4 oxygens 4 into minus 2 is equals to 0. Now plus 2 plus X minus 8 is equals to 0. Minus 8 how you got sir? Plus into minus minus 4 into 2 8. Now minus 8 plus 2 X minus 6 is equals to 0. X is equals to plus 6. The plus 6 is nothing but sulfur. Okay, that is what sulfur is, plus 6. Now check product side. Oxygen minus 2. Oxygen minus 2. One oxygen gaining 2 electrons. 3 oxygens gaining total 6 electrons from iron. Here total 6 electrons lost by 2 irons. Means 1 iron lost 3 electrons plus 3. So this all confusion means you go through the calculation. Okay, 2 irons plus 3 oxygens. Find out iron X you take it 3 into minus 2 minus 6. If you send the side plus 6 by here 2x no iron means 2 irons are there. So you will get automatically plus 3. You can go through like that calculation. Now sulfur oxygen gaining 2 electrons. How many oxygens? 2 oxygens in SO2. So total 4 electrons gaining from sulfur. So sulfur plus 4. Here oxygen gaining 2 electrons. Total 3 oxygens gaining from sulfur. Total 6 electrons. Now you observe the changes. Iron here reactant side iron having plus 2. What about product side? Product side iron having plus 3 oxidation number. Means plus 2 to plus 3 increased. Increased means oxidation. Next sulfur here plus 6. Plus 6 to plus 4. Decreased oxidation. Something what? Reduction. Okay, like that both oxidation reduction takes place. So this also following redox reaction. Understand children? This is about redox decomposition reaction. Means in decomposition reaction how they are showing redox reactions. Okay, next displacement reaction. So here children one note, like combination reactions, there we discuss all combination reactions not shows redox reactions. Only one side elements, one side compounds are the means they will show redox reaction. Same note here also applicable. All decomposition reactions not shows redox reaction. Only whichever having one side elements, one side compound, they only will show oxidation number change. As per that we are giving redox reaction. But see here, this also here I given 3 examples. This also decomposition reactions, but there won't be any oxidation number change. See here, first example, magnesium carbonate decomposes magnesium oxide plus carbon dioxide. Here magnesium plus 2, reactant side Product side also magnesium +2. Next, carbon +4 reactant side, product side also +4. Oxygen -2, product side also -2. There won't be any change in the oxidation number. At the time, they won't follow redox reaction. Just they are decomposition reactions, as well as all decomposition reactions are endothermic reactions. So, decomposition reactions all are endothermic reactions, that is compulsory. But decomposition reactions all are not redox reactions, not follow redox reactions. Yes, displacement reactions. Dear children, one common statement for displacement reactions: all displacement reactions are redox reactions. They will show redox reaction. Okay, common statement: all redox reactions are displacement reactions. See here, elementary form. Zinc is in elementary form, its oxidation number is 0. Sulfate ion -2, copper +2. Next, sulfate ion -2, zinc +2. Copper is in elementary form here, 0. Now changes observed in the oxidation number. Reactant side, product side, compare. Zinc 0 to +2. Increased oxidation number. Increased oxidation number means oxidation. Next, copper +2 to 0. Decreased oxidation number. Of course, reduction. Okay, so one element, one compound displacing and forming again compound and element. So, which is their element reactant side, that is increasing product side. Which are their element in the compound reactant side, that is going to decrease oxidation number. So like that, oxidation number changes in every reaction. All displacement reactions are redox reactions. Now here they will ask mainly questions: which is oxidized, which is reduced, which is oxidizing agent, which is reducing agent. This type of questions in combination reactions we used to observe. Again, in displacement reactions also we used to observe this type of questions. Now see here, which is oxidized, which is reduced. First, oxidized means which is undergoing to oxidation, that is only oxidized. So while giving answer clearly we should give which is oxidized here. Zinc is oxidized to zinc sulfate. Which is oxidized? Zinc is oxidized to zinc sulfate. Zinc is oxidized to ZnSO4. Okay, means which increasing oxidation number from where to where, that we should mention here. Next, which is reduced? Which is reduced? Copper. Copper in copper sulfate. So copper sulfate is reduced to copper. Copper +2, here copper 0. So reduced to copper. Next question, which is reducing agent, which is oxidizing agent? If they ask like that, we have to see only reactant side. Which undergoing to oxidation, that is we call reducing agent. Which undergoing to reduction, that is we call oxidizing agent. So here, which is oxidized? Zinc is oxidized, means zinc is reducing agent. Reducing agent is is zinc, which is undergoing oxidation, that is only reducing agent. Next, oxidizing agent is, which is undergoing reduction, that is only oxidizing agent. Oxidizing agent is copper sulfate, like this. Okay, yes children, this is to you. Try to solve it. Yes, very good. Solve and find out which is oxidizing agent, which is reducing agent, and yes, find out and just send a message. Share your feedback. Yes, oxygen 0, copper +2, sulfate minus, sulfate ion -2. So starting video, 10th class, 13th video, whatever we discussed, that will help you a lot here. Okay, sulfate charge -2, iron +2, copper elementary form 0. Over. Once you finalize the oxidation numbers, very easy to say the which is undergoing to oxidation, which is undergoing to reduction. So iron 0 to +2, oxidation, copper +2 to 0, reduction, +2 to 0, reduction, which is undergoing both oxidation and reduction are called a redox reaction. So these are redox reactions. Now you can write same like this only. Yes, right. Iron oxidized to Fe is oxidized to FeSO4, which is oxidized, which is reduced means you cannot say only iron is oxidized, copper is reduced. That is wrong. Okay, clearly we should write oxidized or reduced. Which is the oxidizing agent, which is the reducing agent means only reactant side we want to see, which is the going to oxidation reducing agent, like that. Next, copper sulfate is reduced to copper, which is oxidizing agent, which is reducing agent. Now, which is oxidized, that is reducing agent. So, reducing agent is iron. Oxidizing agent is copper sulfate. Okay, children. I hope you understand this. Okay, like this only. You can write as a note. All displacement reactions are redox reactions. You take any example like this only. So, note. All displacement reactions are redox reactions. All redox reactions are, sorry, all displacement reactions are redox reactions. Now, next, double displacement reaction. Yes, dear students, double displacement reaction or double decomposition reaction, they won't participate in the redox reactions. They do not show any redox reaction because what is meant by double decomposition reaction? It will formed by mutual exchange of their ions. So their ions exchange takes place, means no charge difference. That is what? There won't be any oxidation number change. So they do not participate in the redox reaction. If you want to check with one example, sodium hydroxide NaOH in aqueous react with HCl, hydrochloric acid in aqueous, it forms product NaCl plus H2O. Now observe the changes, oxidation numbers. Sodium hydroxide ion -1, otherwise sodium +1, oxygen -2, hydrogen +1, hydrogen +1, chlorine -1, sodium +1, chlorine -1, hydrogen +1, oxygen -2. Observe any changes, oxidation number. Reactant side, whatever the elements having that oxidation number, and product side, whatever elements having oxidation number, no change. Same, when the no change occurs, we cannot able to say which is oxidation, which is reduction. So, no redox reaction takes place in the double displacement reaction or double decomposition reaction. Understand, children? Thank you.